In this video, we are going to talk about eventual consistency. We will see what is eventual consistency and why it is important in the distributed system or in the modern distributed system. So let's get started. So first of all, whenever we think about the database, we always imagine a system is there where all the data is always up to date or the fresh data is there and the data is always available. But in the world of a distributed system, achieving this level of consistency can be challenging. This is where eventual consistency comes into the play. In a distributed database, data is often spread across multiple nodes or servers. This setup ensures high availability and fault tolerance. In case of a distributed database, in case of a distributed system or a distributed database, your database are deployed in multiple regions. Okay, so suppose a one region goes down, there will be another region which will be up. So you will be always be getting the data that basically ensures the high availability and fault tolerance. But the data which you are getting is the fresh data or up to date data that we cannot guarantee. But you will always receive the data. But that data which you are getting eventually after some time, that data will become the fresh data, but that will be eventually, not the at a particular moment. I mean, it can be at a particular moment or it cannot be, but eventually it will be fresh data. So that's what it is saying. So but it also means that keeping every piece of data perfectly synchronized at all time is nearly impossible. That's why, like, because region 1 and region 2 is there, region 1 goes down and region 2 is there, because suppose you have updated something and it goes to the region 1, and region 1, now from region 1 to region 2 it has to sync, right? So that there can be a delay in that sync. So that is basically called the eventual consistency. Your data will be consistent but eventual after some time in case of a distributed system. So the cap theorem states that in a distributed system, you can achieve only 2 out of 3 guarantees. Okay, so cap theorem is basically made up of these three guarantees, that is consistency, availability, and partition tolerance. So consistency basically means your data will always be the fresh data. It will always be up to date data. Okay, availability means your data will your system is always available. You are receiving the fresh data or not, that doesn't matter, but your system or your database is always available. So when network partition occurs, so system has to choose either consistency or availability. Okay, so eventual consistency is a type of consistency model where instead of ensuring immediate consistency, the system guarantees that given enough time, all the updates will propagate to all the nodes and system will eventually become consistent. So eventual consistency, that's what we were talking about. The eventual consistency says that the data which you are receiving at a particular moment, that is a fresh data or not, that we don't know. But after some time, eventually, whatever data you are getting will be the fresh data. So now we will understand this with some example. Okay. So first of all, eventual consistency is basically used in the large scale application where high availability is more crucial than immediate consistency. So best example for this can be Apache Cassandra, Amazon's DynamoDB. They will give you the high availability, and in case of consistency, like we can use go for the Oracle or SQL Server, or most of the RDBMS basically gives the high consistency. Okay. So now we will try to understand this eventual consistency with some example. So we are going to take an example of the Facebook. Imagine you update your status on Facebook saying just had the best pizza ever. Okay, now suppose you are sitting in the US. So your friend who is in US will receive your updated status or will receive your status. But your friend who is in Canada is not able to see your that status at that particular moment, like your new status which you have posted just had the best pizza ever. Your friend in Canada is not able to see, but your friend in US is able to see, because the when you post it, it first gets saved to the nearest server. Okay, so the nearest server to you was the US. So that's why your friend who is in US is able to see, but your friend is in Canada is not able to see. But eventually, after some time, your friend who is in Canada will be able to see the fresh data, or the sync will happen, and he will be able to see the fresh data or the your new status. So this is basically called the eventual consistency. Like the data you are receiving at this moment may or may not be the fresh data, but eventually, after some time, that data will become the fresh data. So this was all about the eventual consistency. I hope you liked the video. If you like, please do subscribe to the channel. Thank you.